It's Algebra 2, Lesson 9-5, Addition, Subtraction, and Complex Fractions, beginning on page 562 in the textbook. First thing we have is a definition of a complex fraction. It's a fraction that contains a fraction in its numerator or denominator. So basically, it's a fraction in a fraction, either one or the other or both. Example number 1 tells you to subtract things with like denominators. 11 over 7x minus 4 over 7x. Nice and neat and easy. The denominator is the same. It's just like adding and subtracting fractions. The denominator has to be the same. So when you subtract, you keep that bottom number same, 7x, and you simply subtract 11 minus 4. We know 11 minus 4 is the number 7. So you have 7 over 7x. You can cancel out 7 over 7. And 1 stays on the top, because if you put 0 on the top, then everything's going to turn into 0. 1 stays on the top, and it's over x. So subtract numerators and simplify. Keep the bottom number the same, and just simplify 7 over 7. Take about 15 seconds and do this one just like right on the side of that. 3 over 2x minus 7. Again, the numerator is different, but the denominator, the bottom, is the same. Since it is the same, keep it the same and simply subtract 3 minus 7. We know 3 minus 7 is negative 4 over 2x. The number 2 goes into both of these numbers. It goes into negative 4, negative 2 times, and it goes into itself 1 time. There's no reason to write 1 times x, so you're left with negative 2 over x for that one. Take another 15 seconds and do this one. Again, your denominator is the same. It's x minus 4 at the bottom, so leave it like that. And take 3x and subtract 6 from it. 3x minus 6. Okay, at that point, see if there's anything you can take out. The number 3 comes out at the top 3 times x minus, plus 3 times x plus 6, or 3 times x is 3x, and 3 times 2 is plus 2 over x minus 4. And there's nothing else. Again, this is one of those instances, but there's nothing else we're going to pull out of that one. 3 times x plus 2 over x minus 4. When the denominators are not alike, that's when potential problems start showing up. Again, this is not something that's exceptionally difficult. It's going to take plenty of practice till we feel real good with it. But if you're writing kind of sloppy, you might just lose it in your handwriting. So try to be a little neater with this section. X plus 2 over 4x plus x over 3x squared plus 9x. We can clearly see that the denominators are different on both of those fractions. One of them's 4x, the other one's 3x squared plus 9x. The first denominator, when you factor it, 4x, gives you 4 times x. The second one, when you factor it, they have 3x in common, so it's 3 times x plus 3. Now, your least common denominator, just like when we did it in the bell work, when we had numbers like 2 and 3, we were trying to add in denominators. We made both of them into the number 6. Your least common denominator must have enough to cancel out, or enough to represent both denominators together. Now, what that means is the least common denominator is the binomial x plus 3. That's part of it. And the other part comes from the fact that one of them has 4x and the other one has 3x. Now, 3 doesn't go into 4, and 4 is larger than 3, so you have to count by 4s until you find one that 3 goes into as well, and that's where you get 12x. So 12x is one part, and x plus 3 is the other. So what you're doing is you're changing both denominators to say 12x times x plus 3. That's one of the denominators. The other one is going to be 12x times x plus 3. That is the other denominator. Now the denominators are the same. And then you take the first fraction, set x plus 2 on the top. The second fraction said x. Now from there, you're going to take out what they actually had represented at the beginning. So the first fraction was 4x. So there's no reason to have this x. It cancels it out. And there's no reason to have this 12 because 4 goes into the number 12 3 times. Let me show you a different way. I think this might be more confusing than it's worth. Another way to look at it, x plus 2. We know how to cancel out fractions. 4x plus x over 3x times x plus 3. We know how to cancel out fractions. You multiply everything by whatever the bottom number is, by whatever the denominator is. So if we multiply by what we said the least common denominator is, 12x times x plus 3, if we multiply that one by 12x times x plus 3, and we multiply this one, 12x times x plus 3, we'll cancel out what we don't need. Okay, it's easy to cancel out x plus 3 for that one because that's the same. Then cancel out x for that one because that's the same. And then the number 12, the number 3 goes into itself once, so that cancels it out, and it goes into 12 4 times. So it leaves you with 4x on the right. We're going to do the same with the fraction on the left. There is no x plus 3 at the bottom to cancel out, so that has to go with it. We can cancel out the x outside, and we can cancel out the 12 divided by 4. We get 3 when we do that. So we're left with, and look how, I'm trying to be neat right here, and look how messy I got on the side. What we're left with is on the top in the numerator, we're left with 3 times x plus 3 times x plus 2. That's on the left. On the right, we're left with plus 4 times x. Again, all that is separating it. I kind of jumped ahead a couple of steps into 3x times x plus 3. The same thing's at the bottom. This is how we get to 12x times x plus 3. The denominator's 12x times x plus 3 for both of them. The tops, though, will cancel out like we said. The top of 1 will say 3. When we distribute 3 times x, we'll get 3x. When you distribute 3 times 3, you get plus 9. That has to multiply by x plus 2. So again, 3x times x is 3x squared. That's your first terms. Your outer terms, 3x times 2 is plus 6x. Your inner terms, 9 times x is plus 9x. Your last terms, 9 times 2 is plus 18. When we simplify that, we have 3x squared. 6x and 9x together are 15x. And then plus 18. So the first fraction on the top, its numerator will say 3x squared plus 15x plus 18. That's what we have here. The other one's easier because it's shorter. 4 times x is 4x. So the bottom number is the same now. It's a big long thing, that denominator, but it's there. It's the same, 12x times x plus 3. So what you do is you take the numerator's 3x squared plus 15x plus 18, and you're adding 4x to it, and all of it is over 12x times x plus 3. And you combine what you can combine. You can combine 18, I'm sorry, not 18, you can combine 15x and 4x. And notice we get 19x there. So 3x squared plus 19x plus 18 over 12x times x plus 3, and that's your simplified answer. Okay, copy this problem down on the back and spend a couple of minutes working on just the least common denominator. Separate the second one and see if you can figure out what they have in common. If you factor out that second denominator, 6x cubed plus 3x squared, they both have a 3 in them, and they both have an x squared. When you multiply 3x squared by 2x, you get 6x to the third power. When you multiply 3x squared times 1, you get 3x squared. Now what you need to do is you need to come up with the least common multiple of 3x cubed and 3x squared. The number 3 has to be represented because they're both 3. If one of them was 3 and the other one was 6, then the number 6 would be represented because that would represent both of them. In regards to your different exponents or your different degrees on your variables, all you have to do is represent the largest, or in this case, the larger degree. It has x to the third. That's the one we're going to use. Our final denominator, we're just going to write it off to the side for a second because I think it's easier to just put it back at the end. It's going to be 3x to the third times 2x plus 1. You can't leave off that 2x plus 1. That's what everything's going to be back over at the end. So what we want to do is we want to, just like we did earlier, we want to multiply, not like that. We want to multiply everything by that denominator to cancel out those fractions. 3x to the third times 2x plus 1. That gets multiplied by it, and this gets multiplied by it. 3x to the third times 2x plus 1. Now we can clearly see that we can cancel out 2x plus 1 over 2x plus 1 right there. Simple. You also have 3 that you can cancel out right there. And you also have x to the third power divided by x squared, which means you can cancel this one out, and you can cancel out x to the third and simply leave it with x to the first power. So the right fraction at the top is going to leave you with x times x, because there was an x up there already. And after you put in the denominator, you're going to have an x at the top to multiply by. The left fraction, we see 3x. We can cancel out 3. We can cancel out x to the third, so that's completely gone. So you're left with 4 times 2x plus 1. So when you distribute this 4 times 2x, you get 8x. When you distribute 4 times 1, you get 4. And then when you multiply x times x, you get x squared. All of that at the top is being added together. So simply add the top together, add the numerator together. In standard form, you know you want to write it with the highest degree of your exponents first. So we have x squared as our largest one. So x squared. Then you want to go to x to the first power. It's positive 8, so plus 8x. And then you want to have plus 4. All of that's going back over your denominator that we came up with was the least common denominator, 3x cubed times 2x plus 1. And this is your simplified answer, as bad as that looks. When you subtract with unlike denominators, we'll actually go over subtraction tomorrow. We want to jump to, let's do the checkpoint problems real quick. Oh, in fact, we'll stop there. You can do those for homework.